Hi everyone, I'm Valentina Rossi, the marketing specialist at Zappi Group. I would like to welcome you to this session. Please remember that this session is also being recorded and will be available to watch on demand following this session. If you have any questions during the session, please add them to the Q&A. You can find that tab to the right of your screen. Note that your question will be sent privately. With that, I would like to introduce our speaker, Paolo Patroncini from For Consulting, who will be speaking about ePTO, shaping the future of electrification. Welcome, Paolo. Take the stage.
Good afternoon, Valentina. Good afternoon to everyone. I'm Paolo Patroncini from Fury Consulting. And actually, I would like to have a very brief overlook about the electrical power takeoff, and which is our, into Zappi Group, our background, and what are the next steps of this particular technology. Next steps, because actually, it's a very long journey. This journey started in 1918, so almost more than 1 century ago, when the first commercial tractor has been implemented a power takeoff, so an hydraulic pump basically. Some 20 years later, the next big step was the introduction of the first PTO, but which was rotating independently from the track speed, from the engine actually. And in last decade of past century, it has been made the first big step. So the power takeoff has been electrified, but of course, at that stage, it was present. The only possible power source was the lead acid batteries. So very heavy, very expensive, and so on. It took another about 20 years to have the second generation of ePTO, while in this case the power source was much more advanced and turned into the lithium batteries. So in this case, also the lithium battery represented a big step forward, but was still very much expensive, was still very much and so affecting a lot the payback of the machine, and also in this case very much easy. So it was not really a big jump. Waiting for the third and last generation of the ePTO, still with the lithium batteries, but in this case the problems was solved, because while like on previous model, the work of the ePTO can be done still in a quieter, in a safer environment, and where the crews, the ground crews can communicate freely. But now these modern lithium battery technologies are significantly cheaper, and therefore is still a very big improvement. Talking about the vertical market, so I would like to talk about the construction equipment, the agriculture, and the truck and bus trend. So since we are talking about the electrified PTO, it's important to understand which is the market where this component could work, because actually the electrification of construction equipment, of agricultural and truck is rapidly advancing, and this is driven by the environmental concern, by many technological innovation, and also a global push toward sustainability. Regarding the construction equipment, which is on the left side, the graph on the left side, we can say that is expected in the next 20 years a very significant growth, which will be propelled by probably the stringent, more stringent emission regulations, and also, for example, in the mining, where the reduced of the ventilation cost in the underground could, due to the electrical equipment could improve such, could make such big steps. So it's expected to have more than 120 billions of US dollars for the complete market, specifically for the construction in 2044, sorry. Regarding the agricultural, we can say that the adoption of the electric tractors and other harvesters and other machines, this will improve a lot the market, and it's expected, as you can see, another even if not so high, but still very high. So the increase of the market is very high. The expectation, I would say. On the right side, there is the electric bus and truck market. In this case, also this projection is very high, because especially many big companies are investing a lot into these technologically advanced type of trucks. So there is a very important, how we can say, a global commitment for reducing the carbon emission, which will be a very important driver. What are the challenges? The challenges are, I can say that there are mainly two different types of challenges. The first three in this list are related mainly to technology, which, for example, the first one is that the connections, the communication protocols that are already standardized into the electrical vehicle, so in the cars, are not yet fully standardized into the mobile machine. It means that the ePTO manufacturer cannot have a plug-and-play solution across the different OEMs. Another limitation is still the battery range, because the batteries are still a very important player, and unfortunately, I wouldn't say that could kill the market, but of course, while the price is still a market driver, to have a direct comparison, but we will say later that a direct comparison and the fair comparison between traditional and electrical PTO pass only through the total cost of ownership calculation. Finally, the infrastructure and the access to the high voltage charging system could represent a challenge. Generally speaking, I would say that some other threats to the growth of this market are the economical trends, of course. As much as the GDP is growing, as much as the state can make investment on infrastructure, and also the industrial output could influence the demand of the ePTO, of course, in this type of vehicles. Finally, very last statement, and this could change soon, because I am sure that everyone is reading newspaper. The most important driver probably is the government policies. So far, now the the government are enforcing the OEMs to reduce the emission. But again, this could change soon. What are the next frontiers for the integration of the ePTO? Actually, we may say that a global decarbonization could be improved if there is a synergy, a coupling between, for example, plug-in electric vehicles and the power and transport sectors, where this synergy of transport systems can be only achieved with advanced technologies like charging infrastructures, like power grids, and the interaction, for example, between the so-called V2V, so vehicle-to-vehicle technologies. This is something that could really drive and be a game changer toward this direction. Of course, another important point is that the combination of the ePTO and the communication technology, for example, the real-time data gathering. This is implemented now already. This type of technology, because we have very high-tech tools and also the automatic data collection, which will allow the workers to easily track the metrics, to gain insights into daily operation, view personalized data report, and so on. And for example, the connectivity as well as the IoT, like the real-time locating systems. To be a very much more practical, an aspect important is the predictive analysis and the remote equipment operation that can be implemented with this type of systems in the present, but even more in the future. Okay, so technically speaking, how is it possible to have is it possible to have a solution which a solution of PTO which can be suitable for most of the applications available on the market? Actually, in our opinion, the answer is clearly no, because there isn't any solution which fits to all the potential type of vehicle, of machine. And so it's important to have a dedicated methodology to dimension exactly the ePTO. So actually, for example, we are applying a technique in order to collect all the data, type of, depending on the emission profile, and having then a sort of simulation, which is basically working on different type of emission of profile. So this is, for example, in a representation of the very large there is a very large span of power absorption of the PTO in a different type of trucks with different profiles. So the torque needed can vary from 200 to 600, and the power can be 5 times, the bigger one can be 5 times than the smaller, with also many different duty cycles. So it's very important to make this type of approach, I would say. Why? Which is the main reason of the ePTO? Mainly is the efficiency comparison. Because when we compare the efficiency of the ePTO to a conventional mechanical PTO, there are, of course, several factors that come into play. First of all, is the fuel efficiency. conventional PTO with a conventional mechanical PTO setup, the engine needs to power both the vehicle and also the additional equipment. And also, for example, we are sometimes using a diesel engine which has a rated power of 200 or 300 kilowatt to drive a PTO which absorb, for example, 10 or 20 kilowatt. And this, of course, is something that is very much impacting. Also considering that this is a sort of additional load to the engine, which is affecting the and lowering basically the fuel efficiency. Regarding the energy efficiency, again, as is here, this is typically something that is related to the gears, to the frictions, and so on. So we are having another averagely 10% of efficiency more coming from the conventional to the electric one. Considering, for example, that of course the electric motor are generally much more efficient in converting the energy. So also, for example, the maintenance, there are very much reduced downtime with an electric PTO, and this increases the global efficiency of the system. No doubt that the emission and noise and vibration are very much different, and of course better into the ePTO one. Okay. Regarding, I was talking to our university, which is close to here. Bologna University is very much working on the agricultural PTO. There are studies that proves that specifically for the agriculture, especially on low demanding operation, which are very common into the agricultural application, the fuel saving can reach 10 to 15%. So it's something that is very much valuable, especially from a commercial standpoint. But I have anticipated that an important aspect of that could represent a game changer on ePTO is the total cost of ownership. Basically, what are the parameters that can be considered? Of course, the internal combustion engine fuel consumption, which is the fuel price, and also the conventional PTO efficiency. This is from the standard one. If we consider which is the emission profile, we have to calculate the load factor, the operating time, and which is the PTO power absorption. Finally, other parameters are the maintenance cost, which of course are considerably less in case of electrical solution, the battery cost, the electrical increased efficiency, and the other parameters like the energy price from the grid, of course, and the incentives. This means that actually there are some other, there are also some other parameters like the environmental cost, so which is the different footprint of the energy compared between fossil fuels and from grid. So as you can see here, it's significantly better the condition, the feature of the electrical power source. But for example, if we have, we may have different scenarios. In case of high electricity cost and low diesel cost, probably there are still comparison in between the two cases. But as soon as and this is realistically what is happening, as soon as the battery cost is reducing, and even more as lower the price of the energy, of the electric energy will become, and the diesel or fuel is increasing or at least stable, the beneficial of the ePTO is increasing more and more. If, as we said, the governments are putting incentives to protect the environment, to reduce the greenhouses emission and so on, of course, this is boosting a lot the implementation of the ePTO. There is almost no competition, I would say, in case of usage of energy from renewable sources. Okay, here we have some source. Talking about some more modular and solution and what we have studied, and we in Zappi Group and Fury Consulting we have developed so far, we may say that we can start with a sort of level entry solution. So here on the orange square, we will have the pump basically, and the pump is driven only by the motor and the inverter. Everything else is demanded to the vehicle. The one step more could be the introduction of the radiator and the thermal management system. This could be a sort of plug-and-play solution. So if a truck manufacturer, an electric truck manufacturer, wants to drive the ePTO, at least can put this box and control it via CAN by the vehicle. Another step for a more embedded system is to have the internal control system. So in this way, also with an HMI, with a display, in order to have localized in the box all the diagnostic, the management of the cooling system, and the user, the worker, can work directly on the system with the HMI, for example. One more additional case could be the introduction of a remote diagnostic. So with the GPS locating system, with the active and passive diagnostic and troubleshooting. And in this case, the system is almost completed if we introduce also a power pack with battery charger and the battery. And so the energy which power the PTO will not be drained by the battery of the vehicle, but will be provided by the battery of the system itself. So this is actually a possible, I can say, a retrofit for internal combustion engine powertrains. Typically trucks that they cannot, they don't want to run the engine while the PTO is working. And here we can find some solution about high voltage that we have developed in the last years and months, actually, with the Zappi Group components. And so with Zappi Group, we made the system integration using components from Zappi Group. What are the features that are normally that we can implement in this? Of course, the features are implemented to improve the efficiency, to have a system which is connected to the via IoT, for example, with other users, with a portal or something like this. Of course, cyber security and functional safety, and so on. So this, I mean, depending on the customer demands, it's possible to customize a lot the content of the ePTO. Some examples that we have done for light vehicle duty truck, low voltage, for example, this is an example with its protection, as well as the ePTO for the EV truck version. In terms of agricultural, we have developed several different applications, and it's possible, for example, to have a fully electrified rear PTO. This is on a hybrid tractor. With the same architecture, it's possible, of course, to drive also the pumps. So in order to have a typical ePTO for the accessories, and finally also regarding the front PTO for the lifters and other eventual users. So it's possible to manage a very different variants of solution also for agricultural power takeoff. Maybe I finished. So of course, if you have the need of further clarification, we are here. You can reach me on email or on LinkedIn, whatever. And that's it. I think. Yeah.
So thank you, Paolo. Actually, we have some questions to answer live. So the first one is, what is the impact of connectivity on a fleet of vehicles equipped with an ePTO?
Okay. Connectivity. Yeah. Actually, we can say that with real-time data, the worker can immediately act on anomalies, on failures, for example, from or sudden operational drops, for example, and the decisions which is taken based on this data leads, of course, to better outcomes. So these data-driven choices is evaluating the productivity and the efficiency.
Okay. Are also beneficial the possibilities to have an energy recovery system with an ePTO? And after that, we have the last question.
Yes, absolutely. This is I think the core of the discussion about the ePTO, because for example, the energy recovery during the unloading with an ePTO is certainly possible and is implemented and is very much more efficient than the traditional way, because of course it depends on specific case by case, but again, during the unloading, for example, while dumping trucks or on agricultural vehicles, there is a typical energy recovery. For example, the regenerative braking. For example, when the system can work as a generator, for example, to recharge the battery, and then recovering this kinetic energy and storing the energy again to the battery.
Okay, so is the battery typically charged by the vehicle engine or by a charger in the port, or a combination of both?
Could be both. Actually, it depends on which type of vehicle is implemented the ePTO. If it is an hybrid, the battery can be charged with a generator, or can be assisted, I would say, by an external or an onboard battery charger.
Okay. Another question: how could be the transition for bus float buses on the highest coast, for example?
Sorry, Valentina, say it again.
How could be the transition for buses float based on the highest cost?
How could be the transition? Basically, I think that this question is very much related to an advanced fleet management system. So I would like to, for example, to evaluate. It's better. The answer could be the evaluation, providing the exact evaluation of the total cost of ownership for the fleet, for example, where apparently the first entry cost could be much higher, as I said, 2 or 3 times, for example, comparing a traditional solution to an electrical solution to a traditional one. But in general, the TCO is much more better.
Okay. So another question is important benefit of ePTO seems to be better control of the output speed and torque limiting, but you did not mention this.
Oh,
So
it's yeah, maybe, yeah, of course, I agree. It's correct. It's correct.
and another one, you have mentioned that the ePTO as a tool of advanced agricultural technology. What are the keys?
I think that there are mainly 3 keys. The first one is the autonomy. So the future farm, which will work with autonomous tractors, drones, or self-driving harvesters, and so on. In this case, the usage of the ePTO could even enhance this application.
Okay.
Second is the connectivity and IoT. So I think that this type of network is facilitating the flow of data and ensure that the farmers can monitor, analyze, and then react on their governance of the farm, for example, because
Okay.
they have the real-time data insights. The third aspect could be the data analytics and the machine learning. So, for example, advanced algorithm that can use this data to find patterns for the farmers, and I don't know, for example, predicting trends and offer reaction, for example.
Okay, we have several questions, so I don't know if we will have time to reply to all of you. But in any case, you can send an email to Paolo. So, Paolo, maybe you can share the slide with your basic information. Exactly.
Yeah.
Another question is what type of functional safety and cybersecurity requirements are you seeing? What standards are you seeing as applicable? What performance level? Can you give an example of safety and cybersecurity goals you are seeing?
Yeah. So actually, about the cybersecurity, I would say that we are, especially for the high voltage system, where we are using the last generation of inverters from InMotion. In this case, there is a very stringent path to be compliant with the most recent mainly from automotive cybersecurity regulation. Regarding the functional safety, in the ePTO that we are normally designing, we are using the control systems that are compliant to the maximum level of functional safety, or at least, for example, with the PL performance, something like performance level D or higher.
Okay, Paolo, do you see lower cost ePTO hydraulic system due to the intelligence found in inverters and their capabilities to quickly address change in power requirements?
Sorry, Valentina, please repeat the question.
If you, for example, let me check. Do you see lower cost for ePTO hydraulic system due to the intelligence found in inverters and their capabilities to quickly address changes in power requirements?
Yes. I think that with the electrical system, recently the power electrical system are improving very much the efficiency in terms of driving the motors, and so globally the efficiency is very much improved, and it makes, of course, for example, if we have a more efficient system, we can have a smaller battery and then a lower cost to have the same range.
Okay. And Paolo, how long does it take to retrofit existing equipment? Can fleets do it themselves? And how does they impact the warranty and resale value?
Well, actually, the idea, and we have some experience on this, is that this type of retrofit could be even done pretty easily by the customer. Of course, not the final user, but by the not the OEM, but the constructor of the PTO, for example, which can provide a range of different variants. And for example, in some case, we are providing a sort of kit for this type of retrofit. And as far as we know, if the system is should be approved at least by the truck or by the tractor OEM, and there is no significant impact on warranties.
Okay, Paolo, the last one. When installed an ICE machine, is there a mechanism to start the engine when the ePTO battery approach a low voltage?
Yes, definitely. Yes, it's a matter of controlling the engine management system via CAN, because basically the state of charge of the battery is always published into the network, into the vehicle network, and then as soon as the level, I would say, of the tank is going down, it's possible to start again the internal combustion engine and recharge the battery. Definitely, yes.
Okay, so thank you everybody for attending this session. Please join the next session from the lobby. And thank you, Paolo, for joining us in this session. Bye.
Bye-bye. Thank you very much.